In this video, we're going to talk about the fundamental trigonometric identities, and we're going to simplify some trig expressions using algebra and the identities, and we're going to talk a little bit about odd and even. Now, if you remember from your previous math course, your Pre-Calc 1 course, that the way that we defined an even function was that it had symmetry with respect to the y-axis, which means if I put in a negative x, the exact same output comes out, regardless if it's a positive or negative x for every x in the domain. And when we have that symmetry, we said it was an even function. And then, of course, when we had a negative x goes in and the opposite comes out, the opposite output, or in other words, every sign changes, we called that an odd function. Odd function. And so we're going to need to know odd and even functions in terms of sine, cosine, and tangent. When we look at our unit circle, we are looking at the possible outputs as ordered pairs for the angle of rotation. Now, if we look at the fact that if I do the pi over 6 and I take the cosine of pi over 6 and I square that value, I'm going to get the square root of 3 over 2, the quantity squared. If I do the same thing for the sine of pi over 6 and I square that value, I get 1/2. So I get the square root of 3 over 2, the quantity squared, plus 1/2, the quantity squared. This is going to give me 3 over 4 plus 1 over 4, which gives me 1. So that works for the cosine of pi over 2 and this, or pi over 6. These are both a pi over 6. Both pi over 6. So that works for pi over 6. Does it work for all the rest of them? And the answer is yes. As long as my angles are the same, when I square the cosine of that angle plus the square of the sine of the same angle, this will always equal 1. So we end up with these Pythagorean identities. Sine squared plus cosine squared is equal to 1. Now if we take this and divide everything by sine squared, then we get the second Pythagorean identity, which is 1 plus cotangent, because cotangent is defined as cosine over sine. So 1 plus cotangent squared is equal to cosecant squared. If we take the original Pythagorean identity, which is sine squared plus cosine squared is equal to 1, and I divide everything by the cosine, then I'm going to get this third Pythagorean identity, because if I divide this by cosine squared, I get 1. I divide this by cosine squared, I get tangent squared, and 1 over cosine squared is secant. The odd and even stuff, let's talk about the graphs of these. Now, what we know, odd and even, we can think about it in terms of symmetry with respect to the origin or the y-axis. So here's my cosine wave. My cosine wave on its fundamental cycle looks something like that. But I have a mirror image of that on the other side. So by the way that we define odd and even, that we know that cosine is even. And so it's reciprocal. So these are even. Okay? Now, if we look at our sine wave, so here's the sine of x. My sine wave looks like this. Its mirror image is across the origin. So we know that this point here matches this point here. It's reflected across the origin. So we say that sine and its reciprocal buddy are odd. Now, if we look at tangent, let's do a quick graph of tangent. So here's a quick graph of tangent. You can see without any real work that the tangent, you can just look at it by inspection, at this point here would be reflected across the origin to this point. So tangent and its reciprocal are both odd functions. So we're going to use the information about odd and even functions to determine whether or not the function given to us is odd or even. And we're also going to use that when we start solving for equations that involved trig functions, and also when we start to evaluate trig functions or trig identities. So we're going to start introducing the odd and even now in terms of trig instead of just our regular functions that we learned in our previous math course. So if we're trying to determine whether or not they're odd or even, that I know that cosine of 2 times negative x is going to give me the same thing as a cosine of 2x. So cosine of the angle is still even. Now, with this, we have a mix, so I really probably should go through the process of putting in a negative x. So f of negative x is equal to 2 the sine of negative x, and then the cosine of negative x. Now we know that cosine is even. Because cosine is even, that this is just going to be the cosine of x. Because sine is odd, this has become negative sine of x. So what I now have is negative 2 the sine of x, cosine of x, which then tells me that this entire function together is odd. Because I put a negative x in and I have the exact opposite output sign coming out. Let's take a look at the cosecant. Now cosecant is the reciprocal of sine. So we know that sine is odd. So let's happen if we put in a negative alpha, not that, negative alpha. This is going to be equal to 1 plus the cosecant of negative alpha, which is going to give me 1 minus the cosecant, not cosine, cosine, and I said cosine again, cosecant of alpha. Now, what happened is that this is not the exact opposite. The sign changed between 1 and cosecant, but it didn't change in front. So we know that in this case, this is neither. Okay, now let's take a look at our last example here. We are doing the cosine. So I'm going to put in f of negative beta, which is going to be negative beta cosine of negative beta. We know that cosine is even, so this is going to just give me the cosine of beta. But when I combine it with the fact I have a negative beta in front, I end up with the exact opposite sign of what I started out with, so that I know that this particular function is going to be odd. So my final answer on that is odd. Now we know from previous sections that we do have these reciprocal identities, the way that sine is related to cosecant, the way that cosine and secant are related, and the way that tangent and cotangent are related. Similarly, the way tangent is defined as sine over cosine, and cotangent is cosine over sine. So those identities are not new. The way in which we're going to use them, though, may be new. So let's take a look at what they're asking us to do, which is to simplify the expression. So to simplify it, the very first one, all we're asked to do is think about how it's defined in terms of sine and cosine being odd and even, and cotangent. Now we know that this one is odd, so it'll be negative sine x, and we know that this one is odd, so it's negative cotangent x. Double negatives make it positive, so this just becomes the sine x cotangent x. So that's all that we're asked to do. On the next one, what we're going to do is we realize that there's a tangent that is equivalent or is in both of those two terms in the numerator. So let's factor out the tangent of x, leaving me the tangent squared of x minus the secant squared of x. Again, I'm going to take the fact that cotangent is odd, so this is going to be negative cotangent x. So this is going to be negative cotangent of x. Now, we have a Pythagorean identity. If you don't remember it, if you don't have your formula sheet in front of you, it's not a big deal. The way I always do it is I know that the sine squared plus the cosine squared is equal to 1. Now, this is shorthand, so please don't write this as like this is a given. This is just shorthand for me to find the other ones without having to look at my formula sheet if I don't have it readily available, or to scroll up to find it. Now I see the tangent, which means I must have divided everything by cosine, so then I'll get the tangent squared plus 1 is equal to the secant squared. And so what I have is tangent squared minus secant squared. So if I have tangent squared x minus the secant squared x, this must equal negative 1, because I have moved the secant squared to the left side of the equal sign, the 1 to the right side, so we know that this is going to equal negative 1. So where I am right now is I'm at tangent of x multiplied by negative 1 divided by the negative cotangent of x. Well, my negatives are going to cancel. And I also know that cotangent is 1 over tangent, so I am at the point of tangent x multiplied by the tangent of x. And that's because this, I can think of this as 1 in front, that 1 over the cotangent of x is equal to the tangent of x. So my final answer here is just the tangent squared of x. And that's my final answer. That's what that simplifies to. Oh, and I just thought about this. Tangent and sine and cosine, actually, that's going to simplify some more, actually. So let's just finish that off. Sine x. Cotangent is the cosine of x over the sine of x, which means my sine x's will cancel, and my final answer is the cosine of x. So that's my final answer for that one. Now let's take a look at this example. We've got a bunch of things going on here. We know we have 1 plus the tangent squared, we have cosecant squared, we have sine squared, we have secant squared. So the first thing I'm going to do is I'm just going to rewrite this a little bit. I'm going to take this part right here for no particular reason. I mean, I can go ahead and find my lowest common denominator, but I'm just going to write this as 1 over the cosecant squared of theta, and then plus the tangent squared of theta multiplied by 1 over the cosecant squared of theta. Now the reason I'm going to do that is because I'm now to the point of saying cosecant is sine. So I'm going to have the sine squared of theta, that's this part right here, becomes it's a sine squared. And then tangent is the same thing as, so the tangent of theta, I'm going to rewrite as the sine squared of theta over the cosine squared of theta. And we also know that the 1 over the cosecant is the same thing as the cosine squared of theta. And then secant, of course, is cosine squared, so cosine squared of theta. So where I am at this point is you can see my cosines will cancel, and I'm going to have sine squared theta plus sine squared theta plus cosine squared theta. But these two are the same thing as 1, so this is just the sine squared of theta plus 1. And that's my final answer. There it is. Boom. Okay. The next part is they're asking me to simplify the trig expression by writing the simplified form in the second one. So what I want when I get done is I only want sine. When I get done here, I want only sine. Now, if you get stuck, if you can't see a solution, you don't see that it's starting to shake out after a couple of steps, then go back and try something different. The trig identities you're going to get better at the more you practice. It's like playing an instrument. The more you practice, the better you're going to be at the instrument. And that's what the trig identities are all about. So I just want to say that if you get a couple of steps in, like 3 or 4 steps in, and it doesn't seem to be simplifying, or it doesn't seem to be when we start doing verifying equations and identities, then stop and try something else. So let's go ahead and do this one. And I want to end up with sine. So I'm going to write the numerator as secant is reciprocal of cosine, so that's a cosine of x. And then cosecant is the sine of x. Now, the fact that I see the tangent in the denominator means I'm probably going to end up with a tangent somewhere. I know I want to end up with sine. But what I'm going to do is I'm going to go ahead and multiply the numerator and denominator by the cosine. So I'm going to multiply by the cosine of x. I'm going to multiply this by the cosine of x. And what I'm going to get in the numerator is 1, or actually I want to do sine. Excuse me, I want to do the sine of x. Because I'm trying to get sine by itself. So I'm going to multiply by the sine of x. And I know tangent is sine over cosine. So I'm going to multiply by the sine of x. In the numerator, I am going to distribute it through, and in the denominator, I'm not. So I'm going to get the tangent of x plus 1 over the sine of x, and then 1 plus the tangent of x. Now, these two will cancel, and now I have 1 over the sine, and then I only am in 1 over the sine of x, and that's all that I wanted. Now, if you would have said, okay, I'm going to turn this into sine over cosine, you would have been fine. It just would have taken you way longer. And again, a lot of what you're going to be doing is trial and error. So initially, if you're finding that you can't get the right answer within a couple of steps, stop and see if there's another way of going at it. So don't initially assume that everything has to be turned in terms of sine and cosine. Let's take a look at the cotangent. Now, what I have for the cotangent is cotangent is going to be defined as the cosine of x over the sine of x. And what I can't do is I can't just arbitrarily say, okay, let's go ahead and square the entire thing, because that doesn't happen. You just don't get to square the expression, because for an expression, all you can do is simplify. You can't just arbitrarily just say square it. What you can do is you can multiply numerator and denominator by the same value. You can break it apart, but what you can't do is you can't just say, okay, I'm going to go ahead and square cosine and square sine. That is just not an option, because this is an expression, not an equation. We don't have very many identities to work with cosine and sine at this point. We don't have half angle, and we don't have power reduction or anything like that. So all we really have is the Pythagorean identity, which is the sine squared of theta plus the cosine squared of theta is equal to 1. If I solve for sine squared theta, this is going to give me 1 minus the cosine squared theta. And you can see that I don't have, actually what I want to do is I don't want to solve for sine squared, I want to solve for cosine squared. So I'm going to solve for cosine squared theta is equal to 1 minus the sine squared theta. I don't have cosine by itself, so I can take the square root. The cosine of theta is equal to plus and minus the square root of 1 minus sine squared theta. So I have this replacement, which is plus and minus the square root of 1 minus the sine squared theta all over the sine of theta. And at this point, that's pretty much all I really have, because I only have the Pythagorean identity, and I can't, like I said, I can't just arbitrarily square cosine squared and sine squared. I can't, and if I multiply the numerator and denominator by cosine, I'll get the cosine squared. That's cool. But then I'm going to get a cosine here, which I really don't want to have, because I want to just end up with sine. So be aware of what you can and cannot do with an expression versus an equation. So when you're simplifying these, or when we're doing the identities here in a moment, think about what you can and cannot do with an equation, what you can and cannot do with an expression. So now we're going to be asked to prove these identities. We're going to prove that this equals one side equals the other. So what we're asked to do is to prove that this side equals this side. And when you are doing identities, you want to start with one side and one side only, because you're trying to prove it. What you don't want to do is to add and subtract something from both sides, to square both sides, any of that. To be as rigorous as possible with proving these identities, choose one side, and choose the side that has typically the most amount of terms. And also you want to think about this in terms of sines and cosines. Now the right-hand side is sine, so I'm going to take the information over here. I'm going to see if I can turn it in terms of sine and cosine. And I start out with the odd even stuff first. So I'm going to go inside here, and I'm going to deal with the secant of negative x. Secant is a reciprocal of cosine. So we know that the secant and cosine are even. So the secant of negative x is the same thing as the secant of x. So I strongly suggest that you declare the side that you're going to work on. I'm going to declare the left-hand side. So I do the left-hand side, LHS is left-hand side. I will rewrite the left-hand side before I actually start proving the identity. And that way you all know, and me as your teacher will all know, which side you've declared and what you've started to do. So I start out with the left-hand side. I'm going to leave cosine as it is. Tangent I'm going to turn into the sine x over cosine x. And then the secant is the, we know that's just going to be the positive. Secant of negative x is just secant of x. So this is just going to be secant of x. And further, I know that this is going to be the cosine 1 over the cosine x. So I'm going to rewrite this as the 1 over the cosine of x. Now I'm going to distribute the cosine through, and when I do that, the cosine will cancel in the first one, leaving me just sine x, and it just gives me minus 1, and that is the right-hand side. So then I usually declare, I recommend that you do the same, that you've declared the side that it is equal to where you start and where you end. looking at the next example here, we are again going to want to just pick one of these. Now this has a double equals, so either pick this and prove this, or pick this and prove this, or these two, then that. So we have to decide where we want to start. Okay, so I'm going to start with the left-hand side, the very far left-hand side. So left-hand side, which is 1 plus the sine squared of x over the cosine squared of x. Now I'm allowed to put the cosine squared under each one of those two terms, so 1 over the cosine squared of x plus the sine squared of x over the cosine squared of x, which gives me this middle piece right here. And then I know that cosine, so cosine, 1 over cosine squared is secant squared of x, and then sine squared over cosine squared is the tangent squared of x. And then I know that secant squared, because it's a Pythagorean identity, that this is equal to 1 plus the tangent squared of x. So this is equal to 1 plus the tangent squared of x plus the tangent squared of x. So I'll end up with 1 plus 2 the tangent squared of x, and this of course equals the right hand side. Now on these two examples, I could have chose the right hand side first, but there is less terms, so I won't typically choose the left hand side typically won't choose the right hand side if there's less terms. I don't always choose the left hand side. I choose the one that has the most terms to work with typically. So let's take a look at the next example here. In this example, we're going to again choose the left hand side because I've got two terms. The other side I only really truly have one. So again, I'm going to choose the left hand side. So I have 1 over the cosine of x, 1 plus. Bad on me. 1 plus the cosine of x minus 1 over 1 minus the cosine of negative x. Now remember, cosine is even, so the cosine of negative x is just the cosine of x. So this is going to be equal to 1 over 1 plus the cosine of x minus 1 over 1 minus the cosine of x. Now I'm going to take these two fractions and combine it into a single fraction. And the way that I'm going to do that is I'm going to multiply by what's missing to get to the LCD, which on the second fraction is 1 plus the cosine of x and 1 plus the cosine of x. And then on this first fraction, it is 1 minus the cosine of x, 1 minus the cosine of x. So in my numerator, I'm going to get 1 minus the cosine of x minus 1 plus the cosine of x. In my denominator, I'm going to go ahead and multiply 1 plus and 1 minus. So these, when I multiply them, because this is the difference of squares, will be 1 minus the cosine squared of x. It's a difference of squares. So 1 minus the cosine squared of x. So I have 1 minus the cosine of x minus 1 minus the cosine of x over. Now 1 minus the cosine squared of x, this is a Pythagorean identity. This is equal to the sine squared of x. So this is going to be over the sine squared of x. You can see my 1's will cancel, leaving me negative 2 the cosine of x over the sine squared of x. And I'm going to write the sine squared of x as 1 over the sine squared of x. I'm going to write this as 1 over the sine x multiplied by 1 over the sine x. And when I do that, I get negative 2 the cosine of x over one of those sine x's, and then multiplied by the other 1 over sine x. So when I get done, I get negative 2 cosine over sine is cotangent of x, and sine, 1 over sine is the cosecant of x, CSC, not CSC of x, which does indeed give me the right hand side. All right, so that's it. Yep, that's it. So here is our putting our toe in the water where it comes to doing trig identities. We're starting out with the Pythagorean identity. So at this point, that's all we have is the Pythagorean identities and the odd and even. And we also have cofunctions, so don't forget we have cofunctions. Ooh, speaking of cofunctions, cosine. Oh, yeah, cofunctions. I could have done this one up here. I could have used cofunctions here instead of this. Remember your cofunctions. Anyways, there it is.